Hello viewers, let's continue to discuss the rest of the important components which we left in my previous video, and let's go through them. And before that, I need to talk about a little I need to recap a quick recap which we have discussed in previous video. And in previous video we had a discussion about the cluster history and overview, and also we have discussed the important layers in HAE cluster. We have three different types of layers, and each layer we are running some components, and we also discuss about the components, what are their roles and responsibility, and how they have configured. Okay, so we have discussed about them, and later we talked about a resource agent. We have different types of resource agent and the location where it is available, and what are those type, LSB or OCF, STONIT, and so on. Okay, so those we have discussed, and later in this slide it says about resource constraint, which we did not cover in previous video, so I'm going to discuss this today. Okay, so let's go back to Hawk and click on the resource section, and in resource section we have different type of resources available in a HAE cluster. The first one is primitive. This primitive resource is the mandatory one for anything you are going to use, for example LVM, file system, IP, or anything you name it, like an NFS or web servers. We have to create a primitive. So primitive is the basic resource type which we have to create in order to configure anything, right? So in this primitive I have created LVM and also a file system and also a STONIT device. So those three primitive I have created, so it is just a kind of resource right now, and I have grouped this LVM and NFS to this group grp minus fs. Okay, inside this grp minus fs I have added these two primitive, and they become a group. Okay, so, and I also talk about a little about the template, what is the use of template and why we create template in order to save time, spending a lot of time creating primitive one by one, and specifying those parameters, settings, and all. So we can create in one single time a primitive which is default or standard as per your requirement. For example, in development environment you use 10 GB of file system and some naming convention. So with that you can create those primitive and file system, and you can create a template, and inside the template you can mention development template. And whenever you are going to create a new file system, you can directly go to template, and you can use that to avoid a lot of time spending creating primitives under this section. Okay, so this is why we use template. And also I talk about group is nothing but group of services or group of primitives. We club them in one single group, and they are related to each other. So for example, if you are using a web service, in order to use a web service, what are the basic requirement you have it? You need IP address, and you need file system, and you also need an LVM. So these three are the basic primitive or resource required to function a web service. So you will create three primitive: file system, LVM, and IP address, and you can group them into here. You can create a group called web servers, and inside that you can add all this primitive, right? And for clone we use basically, when you use an active servers, we use clone to provide simultaneous service. Correct. So this is what it is. Master and slave I'm not going to discuss because this is not very much useful, and it is we are not using this master and slave, so it is not of use. But still, if you wanted to know about this master and slave, you can always go and check for CRM array info and check for what are the available how to create your master and slaves. You can check that, or probably you can click on like this and you'll see how to create master and slave and the concept why we use master and slave. Since I'm not using master and slave, and I'm not going to discuss about this one, so and neither that is important to describe or demonstrate my video. So for my video, these are the 4 resource type is enough. Okay, and the last one is regarding the constraint, which we have it here. Again, the ticket last one is not required, sorry, so now this one is not required, so I'm not going to talk about ticket, but instead I'm going to talk about the other 3 which is important and it is required when you are going to configure your cluster. So here it is location, collocation and order. So what are those 3 constraint types? So let me go back to slide now and let me bring this slide up here. Okay, so we have basically 3 types of constraint. So here it says having all the resource configure only a part of the job, even if the cluster knows all needed resources, it might still not be able to handle them correctly. Resource constraint let you specify which cluster node resource can run on, what order resource will load, and what other resources a specific resource is dependent on. So this is similar to in a Redhat environment. When you use a Redhat environment, we have something called one tab called failover node, and also we can specify a child resources under the master resource, saying this is the master resource and inside that this is a child resource. And also we can specify you have to run this first master resource and then you have to start the next child resource, and also the stopping order we have to specify how they have to stop it. So it is kind of a similar thing which we have it in Suse cluster. So there are 3 type of constraint. The first one is resource location. So resource constraint that define on which node a resource may be run, may not be run, or it's preferred to be run. So you are running multiple resource under your cluster, 2 node cluster. So you want your first resource, for example WebFS is your web server resource group, right? So you wanted to run that resource group in node 1, and you have also a resource group called NFS server, so and you wanted to run that NFS server in node 2. So whenever you default start your cluster service, right, so you want them not to manually tell that you start in node 1. So instead we can specify a resource location which will ensure that whenever we start a service, cluster service, that resource will default start as per the location mentioned. So if I specify a web server to be run on node 1, it will run on node 1. So this is how we can specify a resource location. And the other one is resource collocation. So resource collocation is collocation constraint that tells the cluster which resource may or may not run together on a node. So this is a relationship which is called in collocation here. So relationship means for example for NFS servers you need NFS service to run your servers which is a part of a cluster resource, and you also need a file system which is a shared file system, right? And you need 2 things, for example for now basic. So both are relative, right? The NFS service and also the file system. So for example, if I just move the NFS service resource group from one node to another, it will move to another node, but the required file system by NFS server, it is still not moved in the node. It is still in running on the current node. So in that case, IP will functional, IP will available, or service for the NFS is functional, but the required file system which is going to share, that is not going to work, because that is running on the other node. So that's why it will not going to work. So in that case, we will specify a resource collocation saying that this NFS service and NFS file system is a relationship, and whenever I move NFS service from one node to another, it should also move the file system along with the NFS service. So this is the relationship we need, and once you specify the relationship, both will simultaneously move to other node and we will not have any issues. Okay, so for NFS servers, how it works, I'm going to have a separate video for only NFS servers, how to configure NFS servers. There are two types of NFS resource agent we can use in Suse HAE cluster. So I'm going to demonstrate both of them, how to configure them, okay, and how to create this collocation for NFS servers and specify them in cluster configuration. So anyway, I'm going to discuss this later. So for now, resource collocation is what region we use, and the third one is resource order. So resource order is nothing but the order which we wanted to specify. So for NFS servers, we probably wanted to mount the file system first, then we wanted to start the NFS service, and third we want the IP, the NFS server IP, which we want to be available. So that order we can specify how they will going to start, and also we can specify how they are going to stop in order. So first it will stop the IP, then it will stop the service, and then it will unmount the file system and it will move to the other node. So this is the order which use. Okay, so let me so this is how the resource constraint are. So let me go to Hog again and try to expand here. Now I have not created anything for resource collocation or order. Okay, so anyway, I will have a different video where I'm going to create everything and I will show you how to specify them. Right, so this is all about the Hawk web tool, from where you can use your cluster and you can manage your cluster. So next thing which I was supposed to discuss is Pacemaker GUI. So let me open the partition and I will initiate Pacemaker GUI. So the first node I'm going to use, okay, so 192.168, 169, 166, and here I have to enable the X11 like I showed you earlier, why we need this. And in session section it is fine. Let me in window, not window, where it is, yeah, appearance, make the font size a little bigger. Let me make it 12. Okay, and let me initiate xming. It is also important, so I already initiate the xming, and now I will launch the console. Okay, so let me log in. So Pacemaker GUI, the command is crm_GUI. Okay, so crm_GUI is the command where you can use the GUI stuff. Before that, just do a crm_GUI and check what is this location is, and rpm -qa -ql, and check the, sorry, it is q F, we want to check the file is Pacemaker management client package, and rpm -qf ql and the file. So here you go and you will see there are two commands. We can either use hp_GUI or crm_GUI, so both will going to work. So if I say hp_GUI and % to make that runs in background, and here is the window popped up, so and you can log in with your default password and uploading data from server. It is trying to load the data from service. Okay, so it is loaded. let me maximize it to fit the window, and the last option here you can see about the management, and in management section you can see the cluster status. It is all in green, and also you can see the resources running in this system and the resource group which we are running here. So you can do any operation from Pacemaker GUI. For example, if you wanted to move this resource group from node 2 to node 1, you just select the resource group and migrate, and it is saying that your PFS, and you wanted to move to node 1. It is running a node 2 now, and forcefully if you want to do, I don't want to do forcefully, and let it go normal. So now see it got changed, and now it is running on node 1. So how quick it is. So if I just run this command in command line and see which node it is running, I can see everything is running on node 1, right? So you can move the resource group and migrate the resource group from one node to another through GUI. And also in this section, clean up resource. For example, some file system is unavailable. So for example, it is running on node 1, and this is a part of cluster, and let me unmount this file system manually. So but it is a part of cluster, so I did it manually. So let's see how what it happens. So there is a timeout for file system crm configure, so it is already done. So here you can see the running failure ignored OCF heartbeat. This file system is failed because I manually unmount that, right? And also if you just do crm on, you can see a failed action here which says data file system monitor, and this is the timeout value. It is unavailable, and here it is says that failure ignore, right? So in that case, we have some command called crm resource cleanup and the resource name. If I do this, what it will do, it will check for the cluster configuration, and it will check for this file system, whether this file system is a part of cluster or not, and it will check the status whether it is managing by the cluster or not. And if it is managing and currently it will find that this is a failed action and it is not mounted by the cluster, what it will try to do, it will going to start the file system again. Okay, so this is the command which we can do command line, and here also the cleanup we can do. Let me select this and do a cleanup. FS database all nodes, you can specify as single node also, but I wanted to do for both the nodes, and I'll just say cleanup. So once I say cleanup, what it does, it check the cluster configuration, and when it finds that this file system in failed status, not managed by cluster, so it has restarted again, and now it is all green and we are fine here. And also if I now go and check this command, I see that error is gone and it is all good now, right? So this is cleanup we can do. There are other option also. You can put the cluster in maintenance mode like this, or there is or specific resource group you can specify in unmanaged mode. So you are going to make some changes in this group, not all the cluster wise changes you are going to do, only specific to this group. Then specify this resource group and you can put this resource group in manage. So I just put this in manage, so it's saying unmanaged. This is all unmanaged state. And also if I go back here and run this command, I'll see here this is unmanaged state. So now you're good to do your change. And also again, to make it back to the to managed state, I'll click on this. So there are many options here. You can go through one by one what are those options are, and what are their roles and what can be done, right? So those are many options we have it. Okay, so these are the other options. And now let me go to the configurations section and click on CRM config. So CRM config, here is the default setting where you can see the setting about the cluster delay timing 60 seconds. You can increase more or less, it is a default one. And also timeout whenever this two nodes is trying to communicate each other in 60 seconds. If this server is unable to communicate, then the other node will declare the node as dead, right? So you can increase this as per your requirement. And also other option have watchdog. You can use watchdog service which we use for Stoneit. It is currently not in use, so I just checked it. And no quorum policy, you can use any one of them which is preferable for your environment. And other options we have it here. So here earlier in my video of the first video, I believe, or in second video, in Stoneit video, I told about the other actions. The other action is power off and the off. I don't understand what is this power off and power off, but I believe if you do a power off, it will gracefully bring down your system, and if you do a off, it will just shoot your system off, kind of sysreg which we do. Okay, so those are the other options. And the timeouts which we have it here, we can use those timeout, and you can set those timeouts as per your requirement. And if I go to this section CRM, if it is saying yes, okay, I'll save that settings for watchdog. Okay, so here there is saying heartbeat is the default, and it is basically when it is introduced in Suse Linux 9, we used to use heartbeat, right? So that's why we have that option as well, heartbeat. So not sure, let me know. Okay, so now currently I'm using classic OpenAI with plugin, and we have the other option is heartbeat. So if you wanted to use the older version, you can use that, and also the timeout setting and the DC version. Okay, and yeah, so those are the other settings we have it here. You can change them. This is the cluster wide configuration setting. And next we have it here, resource default. In resource default, we have something called resource stickiness 1000 and migration threshold 3. Okay, so I told you that I'm going to discuss this resource stickiness and migration threshold later in my video. So let me go back and try to bring it up here. Okay, so the migration threshold. So what is the migration threshold? Okay, so a resource will be automatically restarted if it is failed. If that cannot be achieved on the current node, or it fails n times on the current node, it will try to fail over to another node. Each time the resource fail, it fail count is raised. You can define the number of failure of resource and migration threshold, after which they will migrate to a new node. If you have more than 2 nodes in a cluster, the node is particular particular resource failed over is chosen by high availability software. Okay, so what does this mean? Okay, so the thing is, see, we are running multiple resource in your cluster. So when for some reason your file system has some issues, and in this resource group you have some issues and it is unable to start it currently, yeah, so it is started, but for some reason some LVM issues or file system issues, it is unable to start your resource group. So what cluster will try to do, it will keep on try to start this resource group. Okay, so how many times it will going to try? So here the resource threshold which we in Pacemaker GUI we have specified migration threshold is 3. That means it is going to try 3 times. If in 3 times this resource is still unable to start by the cluster service, then what it will do, it will try to move this resource group to other node. The other node is node 2. Alright, it is try to move to other node, and once it will try to move to other node, it will try to start there. So this is what the resource stickiness. So we can specify the number as per your requirement, how many times you wanted to try by the cluster. So this threshold we can increase as per that, right? And the other one is resource stickiness. So what is resource stickiness? Here let me go back to slide and talk about a little about resource stickiness. So a resource might fail back to an original node when that node is back online and in the cluster. If you want to prevent a resource from failing back to the node that was running on, or it was wanted to specify a different node for the resource to fail back, change its resource stickiness value. You can either specify resource stickiness when you are creating a resource or afterwards. Okay, so there are values we have it. So value is 0, resource stickiness equal to 0 or greater than 0, 1, 50, 100, 1000, whatever you name it. So you can just use them, and what does their work for? So if you specify a resource stickiness, okay, before that let me just talk about what is resource stickiness. For example, your node is supposed to be running your services or one resource group, NFS resource group, supposed to be running on node 1, and you specify the location saying that you have to run in node 1, right? So when you do that, it is running on node 1, and for some reason your node 1 is down and your resource is migrated to node 2, and currently it is running on node 2. So when your system, when your node 1 is back online, what it will try to do, default, it will try to fail back your resource group to original state or in your system which is node 1, correct? So if you specify resource stickiness 0, this will do that. So if you wanted to fail it back automatically, you have to specify 0, and if you wanted to not fail back, then you have to specify more than 0. So resource, what is the more than 0 value is, the resource will prefer to remain in its current location but maybe move if a more suitable node is available. Higher value indicates a stronger preferable for a resource to stay where it is. Okay, so these are the 2 options, and now there are other options. We have value less than 0. If you specify less than 0, there are 2 types of less than 0 value. Is one is infinity and another is minus infinity. So if you specify resource stickiness equal to minus infinity, what it will do, the resource will always move away from its current location. So if you specify, if your cluster resource is to be supposed to be running on node 1, and you have specified the location that this resource group is supposed to be running on node 1, and for some reason it has migrated to other node during a failure of that node, and if you try to move back that node to move back that service to original node, it will not going to fall back. Why? Because there is a minus infinity, and what is so the minus infinity says that it will not going to, it will always move away from the current location, right? So this is what it will do. So the only solution for this, we have to clear this minus infinity. We can clear this minus infinity, we have command, and also through GUI we can clear them. So once you clear them, then only it will fall back to their original state. So those are the minus infinity, infinity, and values which we have it for resource constraint. So this is a very important important topic we have it here. So we use them when we configure a cluster, right? So let me go back to Pacemaker GUI and see what are the other option. Okay, so this one is operation default timeout. Okay, so and the node details here and the resource details here. One primitive I have created here. Under this there is a group also I have created, and there is a constraint, there is an infinity, you can see here. Okay, so infinity is created for grpfs, crm resource minus clear minus resource grp minus fs. So I clean that resource infinity, and hopefully this would clear, but here it is still showing. Let me see if there is any refresh option here. I don't see any refresh option. Okay, let me see configure show, and here it is still saying, that means it is not clear. I think configure show, what is wrong with this command? CLM minus clear minus resource, I believe. Okay, it looks now cleared. Let me see. Yeah, so the preferred location is now gone, and hopefully here also it is gone. Correct. So now if I click on constraint, I cannot see anything here, so everything is clear. So this is how you can clear. And fencing topology, if you have created anything, ACL, tags, other options here. So this is what your GUI based tool, Pacemaker GUI, through which you can use your system or use your cluster to manage. You can either use Pacemaker GUI, or you can use Hawk. So those are the graphical tools, and very useful. If you do not like command line, then you can go ahead and use these tools. Okay, so I always prefer command line to manage your cluster. It is pretty much quick, and also when it comes to check the logs, command line is always useful. Okay, so this is what it is for this video. The components I talked about a little, and also about the Pacemaker GUI and resource agent. Okay, so in my next video I'm going to create CLVMD CLVMD resource and cluster aware LVM I will going to create, and I will show you how they need to configure and what is their use for. Okay, so that's it for this video. I think if you have any doubts, please write your doubts in YouTube comment section. I will try to get back to you. Okay, so thank you so much for watching this video. Have a good day.